one more inverse problem for good measure here. We're starting with an exponential, and we want to find the ln that is the inverse. So I'm going to start by graphing my original 2 times e to the negative x. So I have a vertical stretch by 2. And my function is going to be reflected over the y-axis. My horizontal asymptote, neither of those transformations change my horizontal asymptote. So it's at y equals 0. My intercept, my y-intercept is going to be affected because I'm going to my usual y-intercept is at 1. I'm multiplying that by 2 because of the vertical stretch. Now, instead of this increasing as I go from left to right, this function is going to decrease because we're flipping it over the y-axis. So usually our e to the x looks like this. When we flip it over the y-axis, it's going to look like that. And kind of having that sketch, for me, I need it. That's really helpful. So my y-intercept I have is 0 to 2. And then I'm going to stretch that other point that's going to fit. Usually I go over 1, up between 2 and 3. So if I multiply between 2 and 3 by 2, I'm going to go up between 5 and 6. And that's the exponential here. That's what's going to fit. My domain for my exponential is all reals. I'm using every x value from left to right. My range is 0 to infinity. End behavior, as x approaches negative infinity, as we go to the left, y is going up. So as x approaches negative infinity, y approaches positive infinity. As we go to the left, we're increasing. As x approaches positive infinity, here we're flattening out to 0. Y approaches 0. Now we're going to find the inverse. So I'm going to change my f of x to y, switch x and y, and solve for y. I'm going to divide by 2 first. Instead of leaving that as x over 2, I'm going to write it as 1/2 x. I know that's going to be nicer for me to look at when I'm looking at doing transformations. In order to get rid of the e, I'm going to take the ln of both sides. Ln of e is 1, but taking the ln not only got rid of that e, but it lets me pull down that negative y. And then I need to divide by negative 1. So my transformations for my new function, my logarithmic function here, my transformations are reflect over x. And the 1/2 inside is a horizontal stretch. By 2. So I need to think through that reflection really quick. Usually my logarithm looks like this. To reflect it over x means that it's going to look like that. My asymptote is going to be the same here as the parent function. It's at x equals 0. x-intercept is going to change because of the horizontal stretch. So usually I go over 1, I'm going to multiply that by 2, so I'm going to go over 2. I'm going to graph this first piece here. That's what that's going to look like. And then usually I go over between 2 and 3. I'm going to multiply that distance by 2, so I'm going to go between 5 and 6 over 1, or down 1. Let's get that reflection. Not the best meet up here. We should be crossing y equals x. So not the best graph I've ever done, but my ordered pairs are nice flips of each other. So my x-intercept here, I'm crossing the x-axis at 2, 0. The domain of my logarithm is 0 to infinity. The range, even though we flipped it, we're still going to get all y values. We're going up forever and down forever. Good to double check that those are kind of what you have above. The domain from the original is the range of our new function. The range of the original is the domain of our new function. And then for end behavior, we can only evaluate this as we go to positive infinity. So as x goes to positive infinity, since this has been flipped down and it's a decreasing function, y is going to go to negative infinity. All right.